All right. Time's moving along, and next Tuesday is when you need to have phase 2 of the project completed, and I think I've seen several of you working on that, writing up your maps and starting to draw conclusions about where the gaps in data are and where you may be able to use logic to identify pipe elevations at a junction where maybe you know the elevation of one pipe and are missing the elevation of another. So I'll be interested to look at your breakdown of the data on Tuesday of next week, and Thursday of next week is when homework number 5 is due. Did I already give that to you last class period? All right, so you've got that in your hands. We've just finished quiz 3, and I've given you the reading handout. We're going to start the class period actually by firing up the computers, and I'd like you to look at a couple of data sources. There's 3 different sources of rainfall data, precipitation data, more correctly, and these are all websites where the data is freely available, and I want us to explore how they're different, what kind of data you can get from each of the 3 websites, and I think the best way to do that is just to have you go directly to the websites and start playing around with it. So let me give you this handout, and if you don't have a computer today, you can get one of the tablets. All right, so let's start with talking about the one at the bottom of the list, the NCDC. Not to be confused with ACDC. Yeah. So what is the NCDC? Did anybody have something written down in their own words they'd be willing to share with the class? What kind of climate data? All right. So how is the, what kind of, let's say, precipitation data? What kind of precipitation data is available there? How is it different from the other types of precipitation data? What can it tell you about precipitation in Ona, West Virginia, for example? John? All right. Let me pull that up. Okay, so GIS, NCDC, NOAA, Gov, Map, Viewer. Oops, app equals CDO. All right, here it is. So precipitation, and it brings up a map of the world. So we'll zoom in on West Virginia. And here's Ona between Barbersville and Milton. So if we wait for it to start to load all the stations, let's have it load the precipitation data here. Not sure why it's not showing. Toggle it on and off. All right, so this is hourly data, and the daily data, there it is, it's showing now. So these are different types of station, this COCO-RA-HS. I'm sure that stands for something. It doesn't matter to me, though, because if you click on this information tool here, identify, and then let's zoom over here to the airport, for example. If I click on identify and click at what's at the airport, it brings up a little summary here, and it says it's the Huntington Tri-State Airport. That's the name of the station. And the data there starts in 1961, and it goes through September 23rd. So it looks like there's maybe a 3-day lag in getting the data up on the website there. And if you want, you can download that data. If you click on it like that, you can get the selected data, and it will actually let you download in tabular format, you know, a CSV file, comma, separated values. You can import it directly into Excel. And so what this has is it has time series data for points. And so what can it tell you about precipitation in Ona, West Virginia? It tells you nothing, because there isn't a gauge in Ona, even though there's an airport, an air park. What's the difference between an airport and an air park? I don't know. But here's some other, okay, so the airports, you know, An airport where there is an FAA presence, like the Tri-State Airport, there's likely to be good precipitation data. But some of these other stations are a lot more iffy. If you click on this Barbersville one, for example, P Ridge PSD, I think that's the Public Service Division, probably like a wastewater treatment plant or something. They've got data from 2001 until looks like the end of July. That's strange. That's a strange that it ends there. Hopefully they're still continuing to gather data. In some of these spots, though, it is stations that are no longer collecting data. It's just, in the past they used to be collecting data. That one seems to be up to date. Some of these up along the Ohio River are old stations where they don't collect data any longer. Here's one from 1937 until 1950. They collected precipitation data in Lesage Greenbottom. Okay, so first of all, who operates NCDC? That's NOAA, the National Oceanic and Atmospheric Administration. And what can it tell you about precipitation in ONA? It can't tell you anything directly. But what you could do is you could say, well, Barbersville pretty close to ONA, so maybe how much it rained in Barbersville gives you an idea of how much it rains in ONA. So this is point data. And this point data is the source of the type of data you can get from the other two websites I asked you to look at. All right, so let's pull up Prism now. And this is not to be confused with the Prism system that is operated by the NSA. No. Okay, so here it tells you who operates Prism. It's the Oregon State Climate Group. It's a university that's funded by a couple of different offices, the USDA, NOAA, and how good is the data? Prism is the USDA's official climatological data, and it's recognized as the highest quality spatial climate data sets that's currently available. Let's click on this map of the United States. This is for August, and I don't want to look at the temperature one. Actually, I want to look at precipitation. Okay, so what can it tell you about precipitation in ONA? Well, you'd be hard-pressed to identify ONA on this map. It looks like a monthly summary. ONA's a little bit further to the east of the tri-state, so it might be in this color range here, between 3.2 and 4 inches of rain for August. Well, it's not just these maps that you can get for ONA. They actually have spatial data as well that you can download for a GIS program. And so if you click on monthly data, then it shows you all of the monthly data that it's got, and if it's right now already set at precipitation, you can look up a map. I think that these are, if you click on this, it'll bring up a map that shows the monthly data for March, for example, March 2013. But more useful is the gridded data. Actually, you can get to the gridded data from here. It says View Gridded Data. And so what this gridded data is that at increments of either 4 kilometers or at 800-meter increments over the entire United States, they've interpolated how much rainfall there is from the stations that are shown on the National Climatic Data Center. So let's go back to the precipitation layer on the NOAA website. So what they do with Prism is they take all of the data that they can get their hands on from this website and they interpolate. It's a spatial interpolation. And it's not just a simple average based on like the Thiessen method that you saw last time or an aerial average. It's a pretty complex algorithm that takes into account the quality of the data at the site, how long a site's been in place, measured amounts relative to typical amounts for an area. And so what the Prism would do would be to take places that, every 2.5 kilometers means that there's going to be a lot of data points between Barbersville and Hurricane, where there aren't any actual stations, but they're interpolating using what has been measured in the past and what data that they do have. So that's the purpose of Prism, and it'll allow you, if you switch to gridded data and you pick, maybe you're interested in a certain month, it's a monthly summary that you can download, and it ends up being a shape file. And remember that you can open up shape files in Google Earth Pro with the license that we've got. Shape files can be opened. Most of the time when people have shape files, they'll open up in a program called ArcView made by Esri. But it's a standard format, and it'll have at every 2.5 kilometers how much precipitation there was during the month of February. And in fact, they also have daily data. I think that if you dig down deep enough, you can find the data on a daily basis rather than just monthly averages. Okay, so that gives you an idea of Prism. And so directly it can't tell you anything about the precipitation in ONA, but it can give you a spatially averaged estimate. And the last one is the Precipitation Frequency Data Server. Okay, who operates that? National Weather Service. And what kind of data is there? Can it tell you about how much it rained during the month of May 2013? What kind of precipitation estimates? Danielle, did you get to that one? Let's pull up the site and take a look at what's there. So we go to dipper.nws.noaa.gov. Okay, you start with the map, and if we click on West Virginia, then it'll immediately bring up this dialog where you see there's this red box, not a box, like a crosshairs. And you move the crosshairs to wherever you're interested in, and you can zoom in on the map if you need to using the standard controls over here on the left. And we see ONA. We drop the crosshairs between Barbersville and Milton. And then what you'll notice is that down at the bottom, it's got a table of data that pops up. Now, it doesn't say anything about whether this is August of 2013 or May of 2013, because this isn't direct measurements of precipitation. What this is it's a statistical table, really. It is a characterization of the types of storms that you would see on average. You know, a 2-year storm, a 5-year storm, a 10-year storm, and right now these are shown as precipitation depths. You can also have it express it in terms of precipitation intensity. So if we switch it to precipitation intensity from precipitation depth, and I go down into the table, what you'll notice is that a short storm, like a 5-minute storm, if I look like the 10-year storm, 5-minute duration, the intensity is 6.7 inches per hour. And the units are listed here at the top of the table, 6.7 inches per hour. But then if I go down, the 10-minute duration storm will have a lower intensity. And we've talked about that before, how the longer the storm duration, the less the average intensity will be over the course of that duration. And it's simply because, you know, the clouds are moving over a storm area. And so the location that has really the highest concentration of precipitation is going to be passing over an area, and so if a storm lasts for a long time, you're going to have some small period of high intensity rainfall, and then more of that overall storm duration will be low intensity rainfall. So the average intensity over the interval of the storm is decreasing, whereas if you switch back over to precipitation depth, so a 5-minute storm has less depth than a 10-minute storm does. And so depth is multiplying the intensity by the duration of the storm. So intensity times time gives you depth. So what can this tell us about the precipitation in ONA, West Virginia? It can tell us the design storm sizes. This is used for the rational method. It's used for a lot of simulation and modeling, but it can't be used to tell you what the weather was like during any one individual month, or even during an individual year. Probably it'd be pretty accurate if you looked at a 10-year period. It might be able to tell you what some of the storms, some of the biggest storms looked like during that 10-year period, but it wouldn't be able to tell you even the precipitation totals during a 10-year period. So we'll come back to these websites later in the semester when we're doing hydrologic modeling, but I wanted to introduce the different types of precipitation data that's out there and what the origin of that data is. Are there any questions about this first look at the precipitation websites? Sure. Yeah. Okay. Yeah. There's a really easy way. If you go to the NCDC, then you pick a point of one of those sites and you'll be able to download it directly, and it'll already be a the CSV file that is in tabular format. So let's say that if your hometown was Barbersville, then you can use this identify tool here, click on the station, and we'll click this box here, get selected data. Remember, I'm recording this in case you need to refer back to how to do this in the future. So I'll just take the entire period of data that's available. It's available from 2001 to 2013. So I'm scrolling down. What I want to have is not the PDF, but I'll ask for the daily CSV. Continue. And I'll take precipitation. I don't need to have any of the rest of this, just the precipitation. Continue. And they've changed this interface, but I'm assuming it's just as easy as ever. I'll write my email address. And it takes them a while to build the file that you're going to download, so that's why they ask for your email address, is that they send you a message when they've gathered the data and the links available. And so you can just leave this page going and check order status, and looks like it's not available to download quite yet. But that's the easy way to get the data that I'm intending for you to access on the homework, is to use the NOAA website, the NCDC. You'll just import it. The file that you download you can open. You don't have to put it into Excel. It will automatically open in Excel. It'll be a CSV file which Excel will recognize should be opened with it. So we'll see if we can. It'll take a few minutes for it to build that data. When it does, we'll come back to it and I'll show you what that CSV looks like. All right. So here are a couple of representations of how precipitation varies on a spatial basis. And it's showing for the United States that the highest amount of precipitation is in the Pacific Northwest. What's interesting, we have another figure that shows that the Pacific Northwest has among the lowest number of days per year on average that experience thunderstorms. So that tells you a little bit about the types of precipitation and during a storm what the event looks like and what's causing the precipitation. I previously referred to rainfall in Hawaii, and what's interesting to look at is along the mountain range in Hawaii, the precipitation is 10 times higher than it is on the leeward side of the island. So in Hawaii, this is the windward side of the island, and over here on the west is known as the leeward side. And you can see that the red indicates between 500 and 800 millimeters per year, and up in the tops of the mountains it can be between 5,000 and 7,000 millimeters per year. So it's an order of magnitude, 10 times as much rain in the mountains as down on the western plains of Oahu. In terms of temporal distribution, what this figure shows is how the rainy season varies from place to place in the United States. That, for example, in Miami you can see that they have the most amount of rain in November, December, October. But then there are other places that have highest precipitation in the Midwest, for example, is during the summer months, July, August, September. And so, and in fact, it's inverted in Seattle. If you look like in Chicago versus Seattle, you can tell that there are very different factors that drive precipitation in Seattle versus Chicago because of when the precipitation actually happens during the year. And this is the figure that I referred to earlier that illustrates thunderstorms and the role they play in precipitation. In the Midwest and down in the Gulf Coast, thunderstorms are really common, and there may be as many as 80 days a year that have thunderstorms in parts of Florida, compared to less than 5 days a year that have thunderstorms along the entire Pacific coast. And so the types of rain events that they'll have along the Pacific coast will generally be a very slow, steady precipitation where there isn't a high peak of intensity, that the precipitation actually is very gradual during the event. And on Tuesday of next week, we're going to look at these generalized characterizations of storm and when the precipitation happens during a storm event. And that's important for design because if all of the precipitation happens suddenly, even during a 24-hour window, if most of the precipitation happens all at once, then that's going to have a big impact on the peak flows that come from a watershed. When precipitation is measured on an hourly basis, which is illustrated here, then a hyetograph is a plot of precipitation with respect to time. And so remember, a hydrograph is a plot of runoff. A hyetograph is a plot of precipitation versus time. And so it has this blocky sort of staircase look to it because the precipitation is being measured over an interval, and so we know the average intensity during that interval because of the way that the rainfall is measured. You can also express the precipitation in terms of an accumulation. So this is showing intensity, and this graph is the total depth of rainfall that occurs. And since it's cumulative, then it'll reach ultimately some plateau when the precipitation stops, and a horizontal line means that the intensity of the rainfall, or the rate, has stopped. And the points on the chart where the line is the steepest, that means that the rainfall is accumulating the most quickly during the steep parts of the line, and that's when the intensity is high. Design storms are what we got off of the Precipitation Frequency Data Server. And often in hydrology, what we'll do is we'll perform a simulation on a watershed using the worst case scenario for the design life that we have in mind. And maybe if a culvert is expected to have a design life of 25 years, then we'll look at what is the biggest storm that ought to come through during a 25-year period. And of course there is a probability that a larger storm could pass through, but if we analyze based on the estimated return period that's corresponding to the design life, then we're able to do a simulation of what the peak flow rate ought to be through an area. So the type of data that you can get is similar to either the depth or the intensity that we were looking up on the Precipitation Data Frequency Server. For example, a 7-inch storm may happen 20 times in 100 years, and so that would have an average return period of 5 years. And that's, of course, it doesn't mean it comes through every 5 years like clockwork. It just means that in any one given year, there's a 20% chance of a 5-year storm occurring. That over the long term, you would expect to see every 5 years that storm to come through. And since rain gauges don't exist at every location that you're interested in, every project site may not have a rain gauge nearby. I did a hydrology project over the summer where I was looking at watersheds all across West Virginia. I had 15 different sites, and at the worst of them, my nearest rain gauge was probably about 50 miles from the outlet. And so it wasn't possible for me to interpolate. There's good evidence to suggest in West Virginia that once you get more than 5 miles from a rain gauge, that there can be radically different precipitation depths. You really shouldn't pick a point and have a rain gauge more than 5 miles away and expect that to be very predictive of how much it actually rains somewhere else. And so what I had to do is I had to use the Prism data rather than a direct point estimation of how much precipitation there is. I used the spatial interpolations that's used by, that's generated by Prism. So here's another look at the precipitation gauges that we have here in the tri-state region. You can see the one that we pulled up for Barbersville, and let's see if that order has been finished here. All right, so you can see there's a CSV download available. If you click on it, it downloads and it opens immediately with Excel. It'll have the date, and it has these other weird fields here, 999999. That means that it doesn't have the data. So if we scroll down, the column that we're interested in is going to be precipitation, and this is tenths of millimeters. It doesn't tell you that in the spreadsheet, but if you go to the metadata on the website, it'll let you know that this is tens of millimeters. And so what this would mean, if you want to convert it to inches, it would be this divided by 254 would give you precip in inches, because there's 254 tens of millimeters in an inch, 25.4 millimeters in an inch, and so this is this PRCP is the precipitation depth.
So is that a temporal millimeter or temporal?
So 20 would mean that there was 2 millimeters. So is that tenths of millimeters, or is that tenths, I guess, right? Tenths. 20 tenths. Okay, 20 tenths means there's 2 millimeters.
I guess it's just easier to input data like that.
You think it's easier to just type them in?
No, I mean, like,
Multiple.
tens of millimeters.
Yeah. It's interesting that we're out of time, so we'll pick this back up on Tuesday, but there are very few sites where the data goes back more than 20 or 30 years. And we're lucky, actually, over in the Eastern Panhandle, we have some of the oldest rain gauges and stream gauges in operation in the country. So we'll try and take a look at that on Tuesday. Remember that for Tuesday of next week, it is the project that you need to have ready for submission. That is due October 1st. Please shut down the tablets as you return them back to the cart. Take them all the way, power down, and I will see you